Good afternoon, colleagues. This is going to be our first lecture in our Applied Data Science with Python course. In this course, we're going to talk about using Python for data exploration, for building machine learning models, and in general about how to solve data science tasks using Python programming language. Maybe you know Python. It's actually a language. It's an interpreting language, and it's one of the most popular languages, programming languages, which are used for data science. It has a lot of libraries, a lot of tools which can be useful for working with data, actually for data visualization, for data exploration, for building models, and so on. And we're going to discuss some of or maybe the most popular tools for doing that. But for the beginning, maybe let's start with give it some formal definition of data science or maybe machine learning tasks. Yes, data science is actually science about data processing, and uh, it has a lot of different techniques, different algorithms which we can use for working with data. But one of the most popular parts of data science is actually machine learning. It's a set of algorithms which can be used to process data and extract some new knowledge or maybe some hidden dependencies from this data. Um, let's talk about that, and let's try to give some definition of such type of tasks. Maybe in this case, it makes sense to start with just a simple text editor, and here I'm going to explain some basic ideas about what is machine learning task and how we can solve it. Actually, usually when we are going to talk about machine learning, we consider some particular set of events which can be described with some set of attributes which we usually call features. And this set of features can be used to produce some particular predictions about our maybe future events, something like that. Uh, maybe we can consider some simple examples. It can be weather forecasting, for example. We want to predict air temperature for the next day, and as a result, we have some data about current air temperature, but maybe about air pressure, about humidity, and so on. And we can use all of this data and try to build some particular model, some particular algorithm which can predict air temperature for the next day using this data. So how we can describe this in a formal way? As we said, we have set of features. Features, actually, each feature it's an attribute which describes our process. There are a lot of types of attributes. We can say that they can be categorical attributes, something like just set of values from some particular range. It can be also real numbers, which can be used to measure some particular values and so on. So for each event or maybe each object, we can use some subset of these features. Usually we try to use all features which we can for starting. Then we can do some feature engineering and filter feature and take only such features which can work where work or maybe give some impact for our results. So suppose we have one object, and for this object we have some set of features. It can be x00, then x01, then x maybe 0n. And also we have something which we usually call target. Actually, this is the value of our um, so our feature which we want to predict. We call such values as targets, and for this particular case we have some value target 0. Then, because we are going to discuss machine learning, and machine learning always uses methods which are based on statistics, and you know that statistics is always about a large number of events or a large number of objects. In this case, it's not enough to have only one event or only one object for given predictions. So in this case we should take another object with another set of features, x01, x10, sorry, x11, and then x1n, and then it's going to be t1, and so on. So we should collect a lot of data. It can be maybe thousands of objects which we can use for building these predictions. And then we have something like xk0, xk1, so on, xkn, and tn. This is our targets. So this is a set of data which we usually use for making our predictions, for building our models. And actually this is a formal definition of task description for our machine learning tasks. And what we are going to do? What is the task for this data which we have? Actually, our task is going to be to build something like algorithm which can be used for taking some particular vector of features and provide the target value for this feature vector. So our task is to create this algorithm. We call this algorithm as a model in machine learning, and our main task is to build this algorithm. And this is how our machine learning tasks usually can be formulated. In general, I can say that almost of all algorithms which are used for this process for building machine learning tasks are well-known algorithms. Some of them are statistics algorithms, some of them use some numeric methods and so on. And what is important in this case is just to find the best algorithm, and also what is also important is find the best set of features for building the model. And then when we build the model, we can try to make some predictions. Then we can try to evaluate model in some particular way. There are a lot of metrics which can be used for different types of tasks, and as a result we can say we can understand if it's possible to build a model for some particular task or not. So let me repeat that again. We have set of features, we have set of targets, and our task is to build a model which take the vector of features and provide the target, which is based on this whole set of data. Then, when we have this formal definition, we can also build something like classification of machine learning tasks. It can be useful to understand what methods can be used in each particular step for solving our tasks. So usually we divide all tasks on two large classes. First class we call machine learning, supervised learning tasks, and another class of tasks, it's unsupervised learning class. What is the difference between these two classes? It's very easy to understand this difference. It is very easy to understand this difference, because in this case we just need to know if we have this target vector. So if we have target vector, in this case we have um, supervised learning task. If we don't have this target vector, we have only data. In this case, we can say that we have unsupervised learning task. Then let's consider some particular examples of tasks for each group. Let's start with supervised learning. It's a little bit maybe easier to understand. What we usually mean as supervised learning tasks. And the first, maybe the most understandable type of tasks, it's classification tasks. Let's try to understand what is a classification task. Again, suppose we want to make some weather forecasting, and we want to say if it rains, it will rain tomorrow or not, for example. Yes. In this case, we actually have two types of classes of targets. Maybe two types of targets. It can be they can be encoded as maybe 0 or 1. 0 means it will not rain. 1 means it will rain, for example. Yes. And actually, this is a maybe one of the simplest examples of binary classification task. Why we call it binary classification? Because we have only two labels, only two classes, 0 or 1, and our task is actually to predict this value, maybe value, just to say if our value will be 0 or 1. We can consider maybe a little bit more complicated cases. For example, we can consider image recognition system or letter recognition system. For example, we have some image which contains some maybe printed text, and of course this text consists of letters, and we want to recognize these letters. How we can do that? Again, each letter can be considered as some particular class. For example, if we have Latin letters, we can consider 26 classes, because in general we have 26 Latin letters, and as a result our task is just to find one letter on our document or our image, sorry, and then classify this letter to some particular class. We call this process as, again, this is going to be classification, but we classify our data for multiple classes. It's not binary classification. In this case, we have multiple classes for classification. Also, we can consider maybe a little bit more complicated tasks. For example, something like text document classification. In this case, one particular document can belong to more than one classes. For example, we want to do something like a semantic classification. We have some maybe domains, and one particular document can belong for something like different domains. For example, it's something like scientific documents. In this case, one document can belong to chemistry and to biology, for example, the same document for two classes. So when we want to classify our data for some intersected classes, in this case we have maybe the third type of classification. But all of these cases actually are examples of classification tasks. And by the way, sometimes it's not really easy to understand what particular type of tasks we are going to solve, and can be also considered as one of the possible machine learning tasks. Then another example of supervised learning tasks, it's regression tasks. What is regression? Actually, our first example with weather forecasting, when we talked about air temperature, it's example of regression. So the difference between classification and regression is that in this case, as targets, we have just real numbers. So our task is to predict real numbers. So when we solve classification tasks, we have values from some particular range. If we solve regression task, in this case, our values are actually they are real numbers, something like that. Let's also say a few words about unsupervised learning, and in this case, maybe the most well-known tasks are a clustering task and dimensionality reduction task. What is clustering? Let me remind you that when we talking about unsupervised learning, in this case, we have only this set of features. We don't have targets, yes. And when we consider clustering, in this case, we do something like classification, but in classification task we already have some labels, some classes. But in clustering, what is the difference between clusters and classes? Actually, for classes we have some predefined groups of objects, but about clustering, in this case we don't have these groups, and our clustering algorithm tries to find these groups. We just have some assumption that there are some groups of objects where our objects are close one to another, and these groups is far enough from another groups, and we will just want to find these groups. And these groups can be used for maybe extraction some additional dependencies, some additional hidden data about our domain, about our data, about our maybe data set. Where we can use clustering, maybe one of the most well-known examples can be recommendation systems. There are a lot of different algorithms for giving recommendations, but one of the ways how we can do that is actually using of clustering. What is recommendation system? I hope you know. Maybe you use some e-commerce sites or maybe even a YouTube site, and you know that when you want to watch some particular video, YouTube recommends you some other videos which can be interesting for you. And actually, these recommendations can be produced with such recommendation systems, with clustering, I mean. We have two ways in this case. We can start with users or with, for example, our videos, and we can just try to cluster them. For example, we can try to cluster to apply clustering for users and find some hidden groups of users. Actually, when we use clustering for real life data, it's very often that it's very difficult to explain why we have such groups. Sometimes it's very difficult to explain. But we can have such groups, and then when we have new user, we can just try to classify him to some of these groups, and then we can see what videos liked by these people from this group, and then recommend the same videos for new user. So this is an example how we can use clustering. Actually, I said that, but I just want to repeat that there are a lot of other algorithms of for giving recommendations, and maybe using clustering is not very efficient approach because it requires a lot of maybe resources. But it's also this approach can be used. And what about dimensionality reduction? It can be considered usually as some additional task which can help us to solve some other tasks. We just very often we just want to reduce number of features in our feature space. Why do we need to do that? Because when we have a lot of features, we also, in this case, we need a lot of resources for working with these features, and also we have some computational errors and so on, so we want to reduce the influence of these computational errors, so as a result we want to reduce number of features. Dimensionality reduction techniques allows us to do that. Sometimes it can significantly simplify our data set, and even sometimes we can find that it's just enough on only one feature to explain the laws which we have in our data distribution. So this is an example of maybe the most well-known machine learning tasks. We also can say that there are a lot of other types of tasks, but they may be more specific type of tasks. So maybe it's a little bit more difficult to discuss them in such course. So I hope that have some understanding of machine learning. We can in general have some ideas what is machine learning, how we can use it. And now let me tell a few words about standard process of solving machine learning tasks, and also about main tools which are used for solving such tasks. Sorry, please. There is a standard. We can find something like, call it CRISP-DM standard. Let's start with wiki, I think, something like that. Actually, this is a cross-industry standard for sorry, maybe I'm sorry, that's good. Cross-industry standard process for data mining. What is data mining? It's very close. Actually, it's a process which is very close to our machine learning process, or maybe data science processes. Data mining is maybe something which is very close to machine learning. So we can consider this process, this diagram, as actually which explains the same processes which we use when we build the models for data science. So what we can see here. There are some particular steps here in this diagram. We usually start with business understanding. And what is business understanding? We have our business, our maybe some customers who wants to maybe to increase the efficiency of some processes, or something like that. Actually, usually these tasks which our business has, these tasks are not formulated in the same way as we do that with machine learning tasks. So usually what actually business wants, it wants to maybe maybe decrease price, or increase I don't know, increase some particular I don't know, some particular features, characteristics, and so on. And then our task is to convert this these business tasks to our machine learning tasks, and sometimes it's not really easy to do. Then we have, when we have a good understanding of such tasks, we can go to the step of data understanding. Usually we have a lot of data in our domain, and in this case we should choose maybe some particular data which can be useful, and also maybe sometimes we need to get some data from outside to build the model and so on. You can see that this process is an iterative process. We have two arrows to the left and to the right. So in this case, we can start to work with some particular data. Then we can see that it's not enough data for solving the task. Maybe it makes sense to change the task, or maybe it makes sense to add data so we can repeat our previous step, and then we can do that more than one time. More than once. Then the next step is, after data understanding, is data preparation. When we find our data, we want to maybe to use them for building models, but sometimes this data is not maybe isn't ready for solving the task. So we should make some preparational steps for data, maybe data conversion, data transformation, and data filter, and data aggregation, and so on. Then, after data preparation step, we can go to modeling step. So we can try to build a model. Actually, model is our algorithm, which we consider when we talked about our task description. So we are going to build this model, this algorithm, and we do that in this modeling step. When model is ready, again, you can see that there are a lot of, it's possible to have a lot of iterations here. Then we go to the next step, which is evaluation of the model. We try to check our model on all data which we have. And after that, we can, it's possible that our model is good enough for solving tasks, so we can go to deployment step, or maybe we can return to the beginning and just say our business that it's not possible to solve the task in such way. And but if model is okay, we can go to the deployment step. We can build something like maybe it can be a mobile application or web application, or maybe a REST API which allows our user to communicate with our model and ask it for predictions. So this is a set of steps which we usually make when we want to solve machine learning or maybe data science tasks. Also, you can find you can see this maybe circle with arrows around all of these steps, which makes this diagram this diagram very optimistic. Because in this case we can say that we always will have some work because we are going to repeat all of these steps a lot of times. So this is how we usually solve our tasks, and the next question is which tools we can use for doing all of these steps. Let's discuss these tools. I want to tell a few words about Python language, about some libraries which you usually use for that, and so on. So for the first, in this case, we are going to use programming language which has name Python. You know maybe that this is one of the most popular languages for data science for now. Actually, it's interpreting language, and we can say that maybe this is one of the most important reasons why Python is used for this particular domain. The problem is that when we work with data, we usually don't know in which particular way we should process some particular data. We need a lot of steps so a lot of experiments just to see how data can be processed, and actually in this case it's really significantly more convenient to work with interpreted languages with something which provides that provides something like interactive mode, when we can give some command or instruction and immediately receive the results. Because if we try to use some other compiling languages like C++ or Java or maybe Go language, in such cases for example, we have some hypotheses how we should work with data, so we should write the code, then we should compile it, then we can run it, and then we can see that our hypothesis doesn't work, and we should start to do all steps again. In the case of interpreted languages, we can just run some command and immediately get the result. So this is the reason why interpreted languages in such cases maybe more convenient. And actually because Python it's a all-purposes language, and it has a lot of libraries, a lot of maybe useful tools, maybe this is the reason why Python now is used for solving such type of tasks. Let me tell a few words in general about this site. I want to show you some useful links here. For example, for the first, here is a download section where you can find the latest version of Python, which is 3.10. Maybe it makes sense to use latest version in this case, because by the way, in 3.10 version we have some significant change in Python syntax. In this version, new concept, which is structural pattern matching, was introduced, and now we can run our code in significantly more readable and more compact way. So maybe it makes sense to work with latest version. Also, here is a documentation section, and here you can find all necessary things for starting to work with Python. But before that, I just want to show you one very important section here, which is PEP index. Let me tell a few words about what is PEPs. PEP, it's actually Python enhancement proposals. Why do we need them, these proposals? The reason why these proposals are created, it's actually just because Python is developed by community. Yes, it's open source project, and each time when community wants to improve the language, they create such PEPs, such documents where new ideas are explained. Then community can approve or reject these documents. And maybe if it is approved, then it can be used for actually making some change in the language. All PEPs have numbers. You can see that there are a lot of them. You can find PEPs with numbers something like 8,000 and so on. And actually, this is maybe the most reliable source of data about some particular decisions in the language. It's easy to understand why some particular things are done in some particular way only from these documents. But in this case, what I want to recommend you to read, maybe we can start with PEP number 8, which is Style Guide for Python Code. It's very important to use the same style of code formatting for all our sources, because as a result other people, our teammates and so on, can work with this code maybe in more efficient way. So this is the reason why it is recommended to follow some particular rules of code formatting, and maybe it makes sense to read this document and learn how to write code maybe correctly. How to follow these rules. I can say that it can be a first homework for this course to read this PyPy document and see how to write the code. Also here you can find a PyPy. Actually, what is PyPy? Is Python package index. Here all packages which are created, maybe all open source languages, open source libraries which are created for Python are collected, and we can find some packages here, we can install them from here, and so on. There is a tool which has name pip, and this tool is always usually is used for installing new packages for Python. Actually, it's possible to have some problems with package installing if you use Windows operation system, because sometimes such packages can require some additional compiling. Now people can allows us to install binaries, but sometimes we need compiling, and it's possible to have some problems with that. So in general, I can recommend, if you are going to use Python, and if you are going to use Python for machine learning in particular, I can recommend you to use some POSIX compatible operation systems for that. Maybe it can be Mac OS, or it can be Linux, and so on. But if you use Windows, in this case, you can try a tool which has name Anaconda. Anaconda, it's just a set of packages which are collected together, and which can be just downloaded. Something like 500 megabytes. You can download them, install, and you will have almost all necessary packages for solving machine learning and data science tasks. But it's easier to use, for example, Linux or Mac OS. In this case, you can just install all necessary packages step by step, and in this case you don't need to install a lot of packages which you really don't need. So I can recommend you to use POSIX compatible operation systems. Sorry, please, colleagues. So for the first, if we are going to work with machine learning and with data science, we need to install Python. Then let me tell a few words about some other libraries which we usually use. On the first step, on the yes, for maybe as the business understanding step, we don't need maybe some particular tools, because in this case it's something like just a communication with customers. On the next step, we usually start to work with data. So in this case, we need tools. What tools can be used here? For the first, we are going to work with data sources, some particular data sources. They can be just files, plain files. That they can be maybe databases. It can be relational databases, or maybe NoSQL databases where our data is stored. Also, in this case, we can have some maybe data warehouses, which usually use something like big data tools. It can be, for example, Hadoop or Spark or something like that. And if we are going to use these tools, we maybe should have some access to some particular clusters where data is stored. And if we are talking about big data. In this case, usually it's not possible to really work with all data which we have, and it is not possible to build models with all data which we have. So in this case, we can just try to use these tools for extraction some subsets of data and then work with them. So on this step, we're going to use tools for working with files, with databases, with big data tools like Hadoop or Spark and so on. Maybe it makes sense to discuss these tools. Maybe it makes sense to start to talk about data science with these tools. So we are going to consider how to read data from files, from some types of files, particular types of files. Then we will see how to extract data from databases. Then we are going to see how to communicate with maybe Spark systems and so on. I'm going to show you some examples of using Hadoop, maybe just main ideas of Hadoop architecture, because now it's not very often case when we really have Hadoop. Now Spark significantly more popular, so we will see how to use PySpark for working with data. Then after this data understanding step, now we have some subset of data which we can process, and for doing that we have some other tools. For example, we can use library which has name Pandas. What is Pandas? It's a library. Sorry. Maybe let's go here. Pandas. It's a library which is created for working with raw data, which is extracted from some maybe even not trusted sources. In such cases, we can have some maybe outliers, something like missing values and so on, and we should do something with all of these things. Also, usually on these steps, we want to do something which we call exploratory data analysis. It means that we don't know nothing about our particular data, and we want to do that, to explore data and understand what may be useful data can be found here. And to do that, we usually use Pandas. Pandas, it's just a tool which is based on some additional tools, maybe more low-level libraries, and one of such libraries actually it's a NumPy library. NumPy library, this is a library which allows us to process large n-dimensional numeric arrays. This library has a lot of actually there are a lot of numeric methods are implemented in this library, and also what is important, this library uses a very efficient representation for numeric arrays, and it is written in C, almost all library. So when we use NumPy, we can achieve the same performance as we can achieve in C when we work with data. So actually this is the reason why we need NumPy, because Python, Python it's an interpreting language, and it is not very fast. It is not it doesn't have a very good performance. So for working with large data sets, we need something more efficient. And this is the reason why we use NumPy. And we actually are going to talk about NumPy. We will see how to use it. Then the next library, it's actually matplotlib library. This library is used for visualization. This is maybe the most well-known library for building diagrams or maybe some plots in for Python. Here we can see, we can take a look at these examples page, and we can find a lot of examples of diagrams which can be built with this library. You can see that we can do almost all possible things using this library, and really visualizations, by the way, it's very important part of building models, so Matplotlib can be really very useful. Also, what's actually also was important that Matplotlib has very good integration with Pandas library, so it's really easy to use Matplotlib for plotting some data from Pandas data frames. Also, there are some other libraries for visualization. For example, we can consider Seaborn library. This library just built on Matplotlib, so anything which you can do, anything what you can do with Matplotlib, you also can do with Seaborn, but Seaborn just simplifies the process of building some particular diagrams for data science. Again, you can go to gallery and see types of diagrams which we can build with Seaborn. And also Seaborn provides some styles, predefined styles, and as a result, when you use Seaborn, your diagram looks maybe professionally. So if you should make some reports or something like that, in this case you can use Seaborn just for making your diagrams maybe maybe more beautiful, something like that. So this is libraries which are used for exploratory data processing. Then on the next step, on the step of data preparation and actually the step of modeling, the library which we usually use on this stage, it's actually a scikit-learn library. This is a library. It's something like maybe standard library for solving machine learning tasks. This library contains 6 main sections for solving different types of tasks. Actually, this is a classification section, then regression, then clustering, then dimensionality reduction. Actually, also we have additional section for model selection and section for preprocessing. This library allows us to actually to do anything which we need from starting with data preparation, with some data scaling, filtering, encoding, and so on, and then we can build models, then we can evaluate models, we can try to find the best model, then we can tune hyperparameters for our model, and so on. All of these things are possible to do with this library. So almost in all cases, maybe we can use this library for machine learning. Then the next step is I'm sorry. Sometimes there are a lot of cases where we can use maybe neural networks for solving machine learning tasks. It's actually a very popular topic, but I can say that in general there are a lot of cases where we can use neural networks. So almost in all cases, it's just enough to use some algorithms which are explained here, implemented here, and we don't need we don't need more than algorithms which are created which are implemented in scikit-learn library. By the way, we also can build some simple networks using neural networks using scikit-learn library. But if you really need such complexity, you really need to use neural networks. In this case, you can use some other libraries. Maybe one of the most well-known library which we use for for building neural networks. It's a TensorFlow library, but in general, I can say that this library is maybe low-level library, and in real life machine learning tasks, it's a rare case when we really need this low-level logic for building our networks. So usually instead of using TensorFlow, we use some other libraries which are maybe a little bit more high level and which can be used just for building networks with maybe some large components, large parts. We can, in this case, we can talk about Keras library, very popular library for building networks. Also neural networks. Also it can be PyTorch library, which is also very popular, and so on. We are going to also take a look at some of those libraries, for example, on Keras, and we will see how to use it for building models. Then, when model is built, we go to evaluation step, and in this case, we again start to use, for example, PySpark. In this case, we want to apply our models for all data which we have, and to do that, Spark provides MLlibs, something like machine learning library, which also implements almost of all algorithms, well-known algorithms for machine learning, and then we can rewrite our code for all data which we have, and run all data and run this code on the clusters on all data which we have, to see if our model works. Then, if our model works, then we can go to deployment step and prepare something like application which can be used for communication with our model. In this case, for example, it can be REST API or web application. We can use something like, for example, Flask framework, web framework, or maybe Django framework, or maybe also something more modern, more asynchronous, for example, Fast API, and so on. We are also going to talk about that. Maybe if we will have enough time, we will see how to use some of them for building REST APIs for deployment models. Also, sometimes when we want to collect data, we can use, if we don't have some maybe sources for our data, we can just try to find data on internet. And for doing that, we can use some tools for scrapping, and one of these tools is Scrappy framework. It's a asynchronous framework which allows us to go through the network and collect data from network. It's also very interesting and also very efficient way to collect data, so maybe we also are going to talk about that. So this is a set of tools which we usually use for data processing, for solving data science tasks, and we are going to discuss almost of all of these tools in our course. We are going to see how to use them, how to solve our machine learning tasks, and so on. So maybe that's enough for today, for this lecture, and colleagues, thank you for attention, and goodbye.